Yo, Luca, check this out. Could you believe this for a second?
No way.
A guy
25,000 feet?
jumps from 25,000 feet above the ground and survives.
I mean, I'm almost levitating. It's incredible.
Ruined. Nope.
How's it going, guys? Today we're going to be solving the question, how did he survive? You saw the video that my friend showed me, and that man in the video jumped from a plane 25,000 feet into a net and survived. To figure out how he survived, we had to do some kinematic calculations. So here are the variables to start off with. We found out that he fell 25,000 feet, which is 7,620 meters. When he fell and hit the net, there was a distance of 12 meters that it took until he hit zero velocity. We assumed that the acceleration is 9.8 meters per second, that he had a zero velocity when he dropped out, and that the mass of this man was 70 kilograms. So here's my calculations here. I use this formula, one of the big five formulas, to find the final velocity for before he hit the net, like right at the moment as he hit the net. So here's the calculations here. I inputted zero velocity, 2 times the acceleration times the distance, which comes to this number. And this was the final velocity. Here's when we arrive to some of the limitations of kinematics. Kinematics assumes that there's a constant acceleration. However, this is implausible in a real life situation because we know that there's air resistance and it has a big effect on the problem. Here, through a bit of research, we found that the terminal velocity of an average skydiver will be 54 meters per second. There's a large difference between what we found through kinematics and what we did through research. So to finish off the calculations, we're going to be using energy formulas done by my friend.
Hey guys, I'm Truman, and I'll be looking into the second component of the scenario, when the skydiver hits the net. So since we're going to be looking at an energy standpoint of the scenario, we have to make a few base assumptions before we can get started with our calculations. So first off, we have to assume that this net has characteristics of a spring, and so therefore it would store energy very similarly to a spring. Also, we have to assume that no energy is lost from friction when he falls from initial height to final height. So to calculate for the energy stored inside the net at the end of the scenario, we have to add kinetic energy with changing gravitational energy from the height here to here. So seeing these calculations, we get kinetic energy, and then we get gravitational potential energy, and then we can solve for the K value found within the energy of the stored elastic energy. From here, we find the value of K, which is equal to 1,531.83 approximately, and so we can measure for max force exerted on the skydiver, where max force is equal to the distance of the spring, which is our net, times the K value, and this gives us approximately 18,382 newtons of force exerted on the skydiver. When searching for the amount of force a person can receive without dying, we sort of found that they could withstand a surprising 46.2 Gs of acceleration. And so therefore, when calculating for what the skydiver could survive, we just do 70 kilograms, which is the mass of the skydiver, times 9.8 Gs, and then multiply that by a factor of 46.2, and then we get this number, which is 31,693.2 newtons. Therefore, since the max force exerted by the net on the skydiver is way less than this number, we can say that he safely survives the impact of the fall.